Hello, this is the second video to section 4.3, where we're talking about the binomial distribution. Suppose we wish to calculate the probability of rolling a die 10 times and getting a 3 exactly twice, or at most 2 times, which would mean 0, 1, or 2 times, or more than 2 times, which would mean 3 times, 4 times, 5 times, etc., all the way to 10 times. Using our graphing calculator is a very nice, quick method we can use to solve binomials. We have a video on this. However, here's just a list of the step-by-step directions, whether you need the number of rolls to equal to, be at most 2, or be greater than 2 times. So you might want to highlight this section here and come back to it when trying to decide which calculator steps you should use. Take a look at example 9, where they're talking about the proportion of people age 15 and over that can read and write. In Afghanistan, the literacy rate is 28.1%. Suppose you choose 15 people at random. Is it more likely that 3 people or 4 people are literate? So what would we plug into our calculator if we wanted to know the probability of exactly 3 people being literate? We would use this binomial PDF function right here, where our n is 15, our probability of success is 0.281, and 3 people, that's our value. And if we plug this into our calculator, we'll get a probability of 0.1927. Let's do the same thing for the probability that 4 people will be literate. And again, we'll plug this into our calculator. The video will show you exactly how to find this function here, and we end up with 0.2259. So the probability of choosing 4 that are literate is higher than the probability of choosing 3. Next, we're asked to sketch a graph of a probability distribution of x. So this means we want to draw a graph for if x is 1, 2, 3, 4, 5, even 0, all the way up to 10. And you can solve for all of these in your calculator, and you'll probably end up with this. You're going to use your binomial PDF function on each of these x values below. And we have a table here of all our probabilities. And we'll go ahead and graph this. We'll set up our x-axis and our y-axis. And just using freehand here, I'll start drawing my bars. And here's my lovely freehand drawing here. And as you notice, when we start getting to 10 and above 10 through 15, virtually these numbers are 0. The last one asks us to find the probability that more than 5 people in the sample are literate. One way you could do this is to add up all of the probabilities that occur when the random variable is greater than 5, like 6, 7, 8, add up all their probabilities, but that would take a long time. Why don't we use the complement here? We can subtract everything less than or equal to 5 from 1. And this will give us the same answer. Notice, since this is an inequality sign, I'm using the cumulative density function up here. And when we plug that into our calculator, we'll get this. And we'll have our answer, 0.2246 or 22.46%. Let's move on to the next page. Take a moment and read example 10. We're asked to find what the probability distribution for X is. And we would write our binomial distribution of our n, which is 150, and our p, the percentage of success here, is 0.09. Now, using our formulas, let's calculate the mean and the standard deviation. Remember, the mean is NP, so that would be 150 times 0.9. And recall the standard deviation is the square root of NPQ. Remember here that Q represents the probability of failure. If the probability of success is 0.09, the probability of failure is 0.91. Next, we're asked to find the probability that 15 people in the sample have access to electricity. Since this is an equal and exact value, we're going to use the binomial PDF function, and we will end up with this. Moving on to letter D, find the probability that at most 10 people in the sample have access to electricity. At most means 10's included, but so is every random variable smaller than 10. And since this is an inequality, we are going to use our CDF, our binomial cumulative density function here. And we'll plug that into our calculator, and when we do, that will be our answer. For letter E, find the probability that more than 25 people in the sample have access to electricity. We'll first write out our inequality, and I'm going to choose our complement again to solve for this. We'll set it up like this. I know this is getting a little bit tricky, and when we do, our answer will look like this. And moving on to our last problem, example 11. Take a moment and read that. After you're done reading this, go ahead and see if you can set up and solve this problem on your own. So this is what we would let our random variable equal. Our binomial distribution would look like this, showing our n and our probability of success. And then we're asked what would be the probability if 22 attended graduation. So we're going to look for this probability, which would be a binomial PDF. And that equals about 0.0280. Now, is this usual? Remember, anything under 5% is unusual. This is about 2.8%. So this is unusual. And that's the end to the second video for section 4.3.